Hello everybody. So many students have been out, whether or not for quarantine or whatever other reason, that I thought that I would make a video filling in some of our notes. If you have this note packet, water cycle, porosity, and permeability, I am going to go to page 3, and I'm also going to do page 4 in this video. Alright, so the water cycle is also known as the hydrological cycle. Hydro meaning water. So this is your upper level 10th grade word, but I'll refer to it as the water cycle. The water cycle is driven by two things. Most importantly, the sun, which is going to cause evaporation and get the water to come back into the atmosphere, and the other one is gravity. Gravity is what's going to pull it back down towards Earth's surface. So most of these water cycle vocabulary words I'm hoping that you already know. I think everybody knows precipitation. That could be rain, sleet, snow, any form of liquid coming down from the sky. Evaporation is when water is going to enter back into the atmosphere. Condensation is when that water vapor condenses back into a liquid. It doesn't fall back down to Earth just yet because those water droplets are pretty small, so they're still suspended in the atmosphere. Transpiration is one that I would say you probably have to go back and review. Transpiration is the same idea as evaporation, except instead of that moisture coming back into the atmosphere from a body of water, it's coming through trees, plants, or any kind of vegetation. Okay, so there's a few blanks in here that are going to be your upper level water cycle vocabulary words. We're right in the middle here, we're going to write the word runoff, which is exactly what it sounds like. That water is going to precipitate from the atmosphere, and instead of going down into the ground, it's going to run off the side of whatever landscape it's falling on. Now, the opposite of runoff is infiltration, which means the water is going to hit Earth's surface and it is going to infiltrate straight down into the ground. It will percolate through the ground until it gets to, there's a dotted line here, and the water is going to collect in the ground, and this is called the zone of saturation. So the zone of saturation because the ground here is saturated with water. Right above the zone of saturation is the zone of aeration, meaning that there is no water in this area. Now, the dotted line represents something very specific, and that is the water table. The water table absolutely moves, and we'll make a little note here of that too. Water table moves. It's not like you dig down into the ground and there's a certain depth where you're going to hit the water table. Sometimes the water table is going to come all the way up to Earth's surface. Sometimes you're going to have to dig really, really, really deep to get to the water table. So what would make the water table go up to Earth's surface? Lots and lots and lots of rain. The more rain, that rain is going to infiltrate down through the ground, but the ground can only hold so much water, and so that line will increase, increase, increase until it actually gets to Earth's surface, and we would result in some flooding. Now, the opposite of a lot of rain is not a lot of rain, and a period of time where there's not a lot of rain is called a drought. And so if there's a significant drought, this water that is stored in the ground is going to come out through transpiration. It's going to evaporate back into the atmosphere, and so that water table is going to go way down. So there's two ways that the water table will move up and down. Okay, there's two vocabulary phrases down here. Sorry, the lights keep going off. Okay. Water that is not absorbed and skids off the surface going downhill. That's our definition for runoff. Water that gets absorbed into the ground and travels down to the water table is infiltration. And if you want to make a note over here, it's an or situation. You're going to get runoff or infiltration. You're going to get more of one thing versus the other. So what determines whether or not you're going to get runoff or infiltration is a whole bunch of variables. And that's what brings us to our next page. Our next page here, the title says infiltration or runoff, because it's going to be one or the other that you're mostly going to see. All right, so for number 1, this is showing gradient. And you can see over on the left-hand side, it is a steep incline. And so if the steeper the incline, the faster the water is going to be able to run down the side of the slope. So we are going to have more runoff here. And for a gradual slope, oh, here comes my rain. The ground is not so slanted, and so I have more time for the water to move down into the ground. So we have more infiltration over here. Okay, number 2. These like X's here are supposed to represent ice. So we have ice in this beaker, or frozen low temperatures, and thawed material over here. So the second variable is temperature. It's really cold out these past couple days, so when you're walking, especially early in the morning, and you step on the ground, usually the ground is a little bit squishy, and it kind of catches you off guard, because when you step on the grass, it's not squishy at all right now, because what's happening is the ground is starting to freeze. So if the ground is frozen and it rains, or we get precipitation, it's not going to be able to go into the ground because the ground is frozen. So we have more runoff when the temperatures are low. And we will have more infiltration when the ground is thawed. So here comes the rain, and the rain is going to navigate through and start to collect in the zone of saturation. Number 3. Really important. When I drew these pictures, I accidentally drew them backwards. So I feel like students don't see this error. So we're just going to cross these out and relabel them. So this side has uniform size. And over here we have a mixed size. All right. What you should be able to see in this picture, let's see if I can zoom in. So these are mixed sizes, all different sizes. There's open spaces in between the big particles, and the smaller particles are able to fill those gaps. When you have a well-sorted, let's label this as well-sorted. If your laundry was well-sorted, you'd have all the same things, like all your socks with your socks, shirts with your shirts. Over here, we're going to call this poorly sorted. And so poorly sorted, again, those open spaces that are in between the bigger particles get filled in by the smaller particles. That would be your sand, silt, and clay. So when it rains, there's not as much open space, and so the particles are going to run off the side here. For well sorted, you could see very easy for that water to go right down into the zone of saturation. So for here we have runoff. And over here we have infiltration. Next. Okay, these beakers look exactly the same. If I said the one on the left is saturated and the one on the right is unsaturated, what would I have to draw in here to show that this one is saturated? That means that the ground is already full of water. So I've got my blue colored pencil here, indicating that this already is saturated. So number 4 is saturation. I think I skipped, number 3 was sorting. Sorry, is it well sorted or poorly sorted? Okay, so saturated. Ground's already full of water. Imagine you had a sponge that was already completely full of water. You try to add more water to it, you're going to make a big old hot mess because no more water can go into it. There's no more open space for that water to go. Even if you had some water down here and you had rain, you still have open spaces for that water to move through. So we would have runoff for a saturated soil, infiltration for unsaturated. If you need to write yourself a note Saturated means full of water. Last one, packing. How consolidated is the ground? So you start out, this line is supposed to show you that these particles started out about the same height as the particles on the right. These are loosely packed over here. And this is tightly packed, we'll say. As you pack down this material, you are pretty much squeezing out any of those open spaces. It's like if I gave the example in class, if you are a baker and the recipe calls for brown sugar, well, usually you have to pack that brown sugar down. If you don't, your cookies or whatever you're making is probably not going to taste so good because you're lacking that sweetness. So you got to pack it down to get rid of all those open spaces. So if it's tightly packed, there's not as much open space. And so you're going to get more runoff. Yes, some water is going to go down in for all the ones that have runoff. Some will go in, but most of it is going to be runoff. If the particles are loosely packed, that leaves plenty of space for infiltration. All right, so these are just some characteristics of the soil that are going to determine whether or not you have runoff or infiltration. Thanks for watching.